The next two columns on your table design worksheets deal with the data types and precision. Here we'll determine what type of data each attribute column needs to be able to store. Each database management system is going to provide a slightly different array of options here, so you'll need to consult your DBMS's documentation to see the specific options available and how to implement them. But there are several common and standard data types that all will support in one way or another. The most common type of data you're likely to store is text data. This is anything that uses alphanumeric characters or symbols. This includes names and departments, but also fields such as license plates or email addresses. In most systems, you'll have a choice between storing small strings of characters or large blocks of text as two distinct data types. The specific number of characters in each category differs from system to system, but most also provide a variable text type that allows you to specify the maximum number of characters allowed. For instance, when storing a name field, a limit of 50 characters is typical. In SQL Server, you would specify this as a data type of varchar for variable character with a precision or length of 50 characters. In Microsoft Access 2013, you'll choose the short text data type and give it a length property of 50. For storing paragraphs of text, such as a book review or product description, we might hit the limit on the number of characters allowed in the standard text data types. If this is likely to occur, then we'll need to create a slightly different data type called CLOB, which stands for Character Large Object. In SQL Server, you'll accomplish this by creating a varchar field with a length value of max. In Access, simply choose the memo or long text data types. Sometimes fields that contain strictly numeric characters can also be stored as text. This might include phone numbers and zip codes, for example. In these cases, a good rule of thumb is to determine whether it would make sense to do mathematical operations on those numbers. And if not, then store the value as a text field. For instance, it wouldn't make sense to add two phone numbers together. When your data really is a numerical value, though, then the DBMS provides several ways of storing those types. The main differentiator is whether you want to store exact numbers or approximate numbers. Exact numbers can be either whole numbers or fractional values, and will use data types such as numeric, decimal, integer, big int, or small int. Each of these variations will have a different range of acceptable values that can be stored. Approximate numbers can also be integers or decimals, but typically represent numbers that are either very large or very small, such as you might find in a scientific application. Here we're talking about numbers above 4 billion, or decimals that are very, very close to zero. Here we'll look for data types such as float, real, single precision, or double precision to store this type of data. Every database management system out there has support for additional attributes. Data types such as date, time, or timestamp will make it easy to both store these values, but also perform calculations with dates and times, which are useful for doing things like determining a delivery date for a product when you know the shipping date and the shipping service. Some DBMSs provide native support for storing time zone information as well, which can be useful if your database is concerned with activities across a large geographic area. The last major standard data type is called a Boolean value, which is easily thought of as a true or false flag, or represented as a check mark on a form. A Boolean data type uses only a single bit of storage space. It can be efficiently used for things like a column that describes whether a customer is subscribed to the company newsletter or not. Anything that is either true or false, or yes or no, or on or off can be stored using a Boolean data type. In addition to the standard data types, some database management system vendors include support for additional data types as a way to differentiate their product offerings. These data types can include support for including file attachments, such as pictures or PDF files, right inside of your data table. Others will allow you to create hyperlink fields that automatically connect to additional resources on the internet. If you're not yet sure which DBMS you'll be using, or if your goal is to maximize the portability of your design across a variety of systems, then it's best to stick with the standard data types. If, however, you know which DBMS you'll be developing in and portability to other systems isn't a concern, then you might find it useful to take advantage of some of the specialized data types unique to your chosen development platform. Take a look through the documentation for data types to see if there are additional options and how to use them. Now that you know a little bit about data types and precision, it's time to fill in the corresponding columns on the table design worksheets. For each attribute, determine which type of data needs to be stored, whether it's text or a number or a date time or Boolean, or choose from any of the custom types that might be available in your DBMS. Then, for text and numerical fields, fill in the precision or length. In the case of text, how many characters do you need to store? If it's a numerical field, Determine if you're storing integers or decimals, and to what level of precision or range the numbers will fall within. Be realistic about your needs and choose the smallest data type that will meet your business requirements.